Okay, today's test is simply to see if I can get the current up higher once the part has reached carry point, and to see if I can use my jack to reposition the parts to keep that current up. I created a little jack down in here. I know it's really simple, but all it really consists of is a little cylinder of wood with a bunch of holes in it and a dowel which can poke through any one of the holes, thereby raising my dowel, my jack. By raising it, can raise the jack up into the work coil. The dowel that you see right here just keeps the jack from falling out the bottom if I screw up. So the jack, of course, is made of wood. It's just a piece of dowel. So to keep the dowel from just burning up, I've got a couple of sort of round flat pieces of fire brick. Here's one that's about 3/8, 7/16 of an inch thick, and here's a piece that's about an inch thick that I've used for other experiments. And so I will drop this down inside on top of my jack, and then set the crucible in on top of that. And then by raising and lowering the jack and picking a different dowel position down below, I can set the height of the crucible wherever I need it to get the current as high as I can afford without going over current. And then, in the case of ferrous materials, as we know, once the ferrous material reaches the carry point, the current drops significantly, by maybe as much as half or so. Okay, there's me pushing up on the jack. If I do get to the point where that works, I will be pretending that I'm a temperature controller again. But for right now, I don't need to insert a thermocouple until I see what the current's going to do. This is the empty crucible that I was using yesterday, and I just put this small piece of pipe in there. And so once I got up to the carry point, I was only getting about 12 amps. So here I have a bigger piece of pipe that I'm going to put in the plain crucible, and we'll see what happens. Circuit breaker is on, power is on, 6 amps. I know the camera's farther away, so I don't know if you can see that or not, but I'm telling you, it's 6 amps. Water temperature 17.9 Celsius. Heatsink temperature for the solid state relay is 66.5 F. Thermocouple, which is just hanging in the air, is 18.7 Celsius. So I'm just going to put this in here and see how far down I can put it before the current goes to 40 amps. 30, 40, that's about as far as I want to go. So now I'm going to push up on my jack. Whoa, the current's too high, 45. Now it's 35. Let me see if it'll turn off. Turns off. Turns on, 36 amps. Timer start here. 38 amps. Whoa, 40, I just went the wrong way. 36 amps. It's getting red in the bottom already. 36 amps, 36 amps, and it's about halfway in. Now it's going down 32 amps, 30 amps, 30 amps, 28 amps, 27 amps. Now I'm going to lower it back down to get back to 30 amps. Now we're at 30 amps again because I've lowered some more of it in there. Remember, this is a plain Crucible, no graphite. Back to 28 amps, 28 amps. Let it down a little further, 30 amps again. Will it turn off? Turns off. Turns on, 30 amps. Down to 28 amps. 1 minute into the test. 27 amps. 26 amps. Going to let it down a little more. 30 amps again. 81 degrees on the heat sink for the solid state relay. This is probably the longest I've had it on at this high of power since I put the solid state relay in the circuit. 26 amps. Going to let a little more down here. Get back to 30 if I can. Back to 30 amps. Heat sink temperature 83 degrees Fahrenheit. Back to 28 already. Push it down a little more. 29 amps. I think it's all the way down now. 30 amps. Good, because we were only at 12 amps when we had the thing on full time yesterday. Now we're back to 26 amps. Okay, 26. Now I'm going to put the thermocouple in there just for grins. It's touching the inside of the pipe. And we're 24 amps. That's twice the current that we had yesterday. So far it seems to be holding at that number too, by the way. Heat sink is up to 86 degrees F. Temperature 708 Celsius. Okay, I'm going to try to control it now. 23 amps. I'm going to try to control it at, let's say, 775 Celsius. It's reading 786 now, so off. 795, 796, 797, 796. What did I say? 775. Heat sink temperature 86 F. Temperature is dropping back on the Crucible 775. Turn it back on again. 28 amps, 26 amps, 25 amps. Again, that's twice as much power as we had yesterday. And I'm shooting for 775 because I'm pretending to be a controller. 3 minutes and 50 seconds into the test. Off at 781, 782, 782, 781. See, the higher temperature, the easier it is to have tight control. 775, on again. 26 amps, 25 amps, 24 amps. 771, 772, 73, 74, 75, turn it off. 76, 77, 78, 78, 77, 76, 75, 74, 73, 72, turn it back on again, 26 amps. 4.5 minutes into the test, and the big point here is the solid state relay is still working. Right now the temperature of the heat sink right below the SSR itself is 83 degrees Fahrenheit, which is really just nice. I'm putting my thumb on the top of the SSR. Whoops, I went too high here. And I can feel it's just a little warm. I mean, put your thumb on your forehead, it's probably that warm. So it's not a very big deal. 91, 89, 88. Now turn it. Well, I'm after 775, aren't I? I did put a piece of insulating material on top of the crucible. That certainly has got to help stabilize the temperature also. 775, 4, 3, 752. Turn it back on again. What did I say? 775, 750? I don't know. Doesn't matter all that much exactly what it is, because the idea, I guess it was 7, I don't know what it was. Anyway, we'll pick 750. Remember, this is Celsius. So I'm at 768. 772. Remind myself, 750. The point is the solid state relay continues to turn things off, and the temperature is 80 degrees Fahrenheit on the solid state relay. I'm going to bring it up to 775 for an average, because I want it on more percent of the time, just in case anybody's wondering about that. I'm going to bring it up to 775. Temperature of the SSR went down to 79.3. 777. So I'm going to turn it off and try to toggle right around 775, plus or minus 2-3 degrees, something like that. 775, I said, right? $768. I let it go a little too far. That's what I get for looking around. For anybody who's interested, the frequency when it's on is about 43.15 kilohertz. 771, 72, 73, 74, 75, 76, off. And it goes off. Big deal. But it works. Water temperature, 19.2 Celsius, in other words, not even warm. 771, back on again, down to 769, 770, current's back up, it's 23, 24 amps, something like that. So we're holding that quite well. 779, 780, off. 8 minutes into the test. I think we'll do this for 10 minutes, and then I'll just conclude, hey folks, it works, you know. Oh, 775 I was going for. 775. 775. Get my ons and my offs mixed up here. 779, 780, off. Water 19.5. I think the water's a little warmer than that. I'll have to check here. 771. Turn that back on. Where's my water thermocouple? Let's see. Oh yeah, it has fallen out, so that's a bad number. Water temperature. There we go. 784, higher than I'd planned. It's interesting, the SSR heatsink is 77 degrees. I guess we got that 80-some degrees out of it when we heated the whole thing up from scratch, huh? 777, 6, 5, 4, 3, turn it back on again. Again, 26 amps, dropping to 24. 10 minutes into the test, 43.16 kilohertz. 778, turn it off again. And it turns off, so that's success. 779, 70. I don't know what to do. I mean, this thing it works just fine. And what have I done different from yesterday? I have just used my little jack that you can see on my cast iron melting video so that I can lower the crucible in to maintain the best possible temperature or the best possible current. And again, as I said yesterday, if you're picking a workpiece that where you can't get enough current, you just need to think about coil redesign and way of proportionally lifting the work out and lowering it down if it's ferrous after it's reached the Curie point. If you're melting things in a graphite crucible, that's usually not much of an issue. The current doesn't change that much. 792. I think we're going to call it. I don't see anything else to do. Water temperature got up to 30 degrees Celsius, which is, I don't know, what is that, 80, 90 degrees Fahrenheit. Heat sink temperature 76.6 right now. Again, just not even really warm to the thumb on the top of the thing. And it's been switching off 100% reliably. So all I can say is, hey, that works. And here at this temperature of about 750 Celsius, which is, I don't know, 1200, 1300 degrees Fahrenheit, be a good hardening temperature for a lot of steels. I can control it within, I'd say, plus or minus 10 degrees with my hand and watching this thing and talking to you. So if I had a controller on here, which might be in the mail right now, you know, I think that would be not an issue. So 12 and a half minutes into the test, 22, almost 23 amperes still. That's 20 times 50,000, 1100 watts, 1200 watts going into the work. What can I say? Well, let's just heat it up. Let's see how hot it'll get. I've got that piece of iron pipe that's in there partially covered. Yesterday with that smaller piece of pipe and only 12 amps on the meter, we couldn't get above about 710 Celsius, and right now we're at 830 Celsius. And if I count for a while, 841, 842, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. It's going up about a degree a second. Let me just turn this off to make sure it's still up. I heard a noise. I heard a little pop. I think the inside of that pipe is, yeah, it's in here, is galvanized, so we might see some smoke coming out of there. 882. No, I don't see any yet. 14 minutes into the test. Heat sink 78.3 Fahrenheit, 900 degrees Celsius. On the work piece, 14 minutes into the test. Water temp 32.8 Celsius. Remember, 100 degrees Celsius would be boiling water. Oh, what did I say? Water, 33 degrees Celsius. That's the cooling water. Okay, so that's only what, 90 degrees Fahrenheit? Something like that. Whereas this 929, 930 that we're at is, I don't know, 1.8 times that plus 32, whatever that is. 2 times that would be 1800, so call it 1600 degrees. And we're at 21 amps still. 21 amps at 48 volts. We're past 15 minutes into the test. Temperature's still going up, 948, 49, 50, 51, 2, a little slower than 1 degree per second. Turn it off just to make sure we can turn it off. It goes off. Great. That's almost twice, still almost twice the current we had yesterday. Remember, this is a 40 amp solid state relay, and I've been thinking in general you want to size that DC to DC solid state relay that's only switching the output of the power supply I try to select for one that's rated for twice what you're actually going to need. I will note that at one point when I was not paying close attention here a while back, I did actually push the thing up to around 44, 45 amps, and it did not immediately burn out. So there's that going for it. 980, 981, 82, 83, 84, 85, 86, 87, about 1,000 degrees. Looks like we'll get easily to 1,000 degrees Celsius here. 1,000 would be 1,832 degrees Fahrenheit, I guess. "16 minutes and 50 seconds into the test now. 21 amperes. Heat sink now has finally gotten back to 81 degrees. Not even really warm to my thumb. 81 degrees F at the heat sink isn't much. There's 1,000 degrees Celsius, 1005, 1006. What else can I say? 36.2 Celsius water, cooling water. 17 minutes into the test. I just have to say that's enough for now. We can use an on-off controller to keep a piece of work at a more or less constant temperature with this unit. Thank you guys for watching.